Okay, hello my friend. So I'm going to explain you how to use the programs I'm going to send you. Okay, there is a folder, okay, in which you will find all these files, all these MATLAB macros. Okay, the first thing that you have to do is to open MATLAB. Okay, so and you will find these files. Okay, this file. The most important file is this one, main.m, which is the main program, my main script to run the analysis. Okay. These three additional files I just added, they are equivalent to the test number 5, test number 6, and test number 7 with a smaller name. Okay, so don't worry, they are included just to do the test. What you have to do is the first thing that you have to do is to set all these variables. Show plot is an option in which you can see more detailed plots that are generated during the analysis. Usually you can put 0, okay? You only need to put 1 in case you see something strange and you can see what is going on. You can put here 1 and he will show you some plot that I will explain you later. Here you should set the number of files that you're going to use to calculate the pedestals. And here you set the name of the 3 or 4 files that you are using to calculate the pedestal. No? Now you acquire only 3 different pulses, no? 400 millivolt, 800 millivolt, and 1300 millivolt. So you need to put only here 3. And here you declare where the path, no? And the name of the files. Okay? And here in voltage, you should put the values, on millivolt if you want, of the voltage, the amplitude of the pulse that you use it. Okay? So this is the only thing that you need. Okay. When you press run, what is going to happen is that there will be a cycle, a loop, in which you will analyze every single file, the first one, the second one, the third one, and in this line will be extracted the threshold and the rate for each channel between among others data, no? And they will be saved here in the variable data. Then there are additional functions, extract noises and signal, in which you will get the levels, the threshold minimum and maximum, or in which the signals start and ended, and where the noise start and end. Okay. There is also this additional function in which you will plot the signal and the noise for each channel. The signal in blue, the noise in red. He will use the file names just to put in the functions. Sorry, in the figures. And then here in this variable data are going to be saved the maximum values of the signals. Okay, these maximum values of the signal are then used to calculate the gain and pedestals. We need the voltage and we need the maximum of the signal to calculate the gains and pedestals. We also need to set if you were injecting into the odd channels or if you were injecting into the even channel. It's very important to write the word odd with S just to have the same length of even, no? Because there is a function that compares if you are writing here odd or even. So if you only write odd, it will give you an error. Okay, and finally you are saving here in this function, sorry, in this MATLAB matrix. You are saving the values of the channels, the gains, and the pedestal that you extracted from using these three files. Okay, here you want, you can explain that, or you can explain that you are using the channel odd and DAC 63 in such a way that the final results will be saved with this name. No? So when you run it, you will obtain different plots. I will show you. And this is the most important plot in which you have the gains and the pedestal for the odd channels that you were using. Okay, this is the gain, and this is the pedestal. The work should be to try to optimize the internal DAX just to have all the pedestals of the same position. Okay, the other plot that you will get is this plot. This is the plot in which you can see the fit, the linear fit of the threshold in function of the voltage. Okay, this is something I have to date because here is saying only X and Y. This is the plot I was talking before, in which you have in red the level, where the noise started and ended, and in blue where the signal started and ended. You see that you were injecting in the odd channels, but there are some signals, some crosstalk also in the even channels. And we have three plots like this because we were using three files, so there is one plot for each file. Okay, and that's all. Okay, in case you get something strange, you can activate here the show plot options, in which you will generate more additional plots. This additional plot, I will explain you here what's the meaning. Okay, so the additional plots are just the visualization of where the noise and the signal, how the noise and the signal were extracted. This is the plot for the signals, and this is the plot for the noise. You can see there is some peaks in which from which I extracted the noise region, and there is some peaks from where I extracted the signal region. Okay, so this width, this amplitude of the signal is equivalent to the amplitude in the blue bar. Okay, and the amplitude of the noise here in X is equivalent to the amplitude of the red bar. Okay, let me see. Okay, continue working. Okay, so basically that's all. We will need you have to generate some results like this, in which we are saving the channels. Channel in this case are the odd channels. We have also the gains for all these odd channels, and we have the pedestals here for the odd channel. All this information, clear all this information is saved here. Okay, if we load, we have all the information again here. So the idea then will be to use all this information for odd and even channel, for DAC 63 and for DAC 0, to do the optimization of the DACs. That optimization I can do it. Okay, so I will ask you to generate all these results okay? Because to do the optimization, we need all these results. I don't have the MATLAB function or MATLAB script to do it, okay? But I can do it when you finish the analysis, and when you have all these uh, files, I can generate a script just to do the optimization, okay? So I apologize for the delay. It was really I had to do it everything from zero, because I was getting some errors when I tried to run my program directly with these new files. But at the end, I could finish. Okay, so I will send you this together with the video. In the case you have any doubt, you can write me, and we can also, if it's needed, we can do a video call, no? Or a meeting, no? Just to show you and explain you anything. Okay, so big hug for you, cheers, and good luck. Okay, good work. See you.